going to put this all together, right? So we want to solve this guy no different than how we would solve like a minus 2a squared equals 0. We want to just factor out that sign as a big chunk and solve for sine as if it were just an x, right? So that times that equals 0. We know that either the sine of x is 0 or 1 minus 2 sine x is 0. So if we solve that, that's sine x equals 2 sine x is negative 1, so sine x is half. So either sine x equals 0 or sine of x equals negative, I can talk, equals a half. And so now to solve for that x, you're basically taking an inverse sine of both sides. But you won't be imposing the domain restrictions, but you're undoing the sign by doing the inverse. And so you're thinking, what angle gives me a sine of 0? And you bring up your unit circle and try to find out where the y value is 0. And the y value is 0 at 0 and pi. And so that's if I just go once around my unit circle, just 0 and pi. The sine of x is a half at pi 6 and 5 pi 6. So if I'm just going once around the unit circle, those are my 4 answers and I'm done. But maybe I want to go, I know that I could keep going around the circle as many times as I wanted. So there are an infinite number of angles whose sine is 0. There are an infinite number of places where my graph would cross that. So what I could do is I could say, well, for this one here, I could just take the pi 6 and I could add 2 pi as many times as I want, so we do that a lot. Pi 6 plus 2 pi k for some integer k. And do the same thing for 5 pi 6, just take the 5 pi 6 and add 2 pi k as many times as we like. And then for this one, I could do the same trick. I could take both of these and take 0 plus 2 pi as many times as I want. I hope that was in screen. And then the pi, take the pi and add 2 pi k as many times as I want. And that would be true, but it would be a bit redundant. So instead, let's just take the 0 and add, because they're 180 apart. They're pi apart. So if I just took the 0 and added pi k times, then that is better. So, and of course we don't need to write 0 plus. So we'll have our pi k and those guys, and those are all our answers to that lovely equation. Hooray!